The benefit concert raised enough money to send 6 children to Disney World, the best year so far. 2 turtles and a sloth have been having a friendly competition between their rival band, the 3 penguins. The following graph shows the average amount of money each band has raised in the last 5 years. So, question 1, who raised more money per year? And then explain. So looking at this, 2 turtles and a sloth is the blue graph, and 3 penguins is the green graph. Couple different ways that we could look at this. We could actually figure out how much they made per year. So looking at this, we could use 0, 0 as a point. This, since we're looking for a rough estimate, we could go ahead and use year 2 as a nice little estimate. Again, how much did they make per year? It looks like they made 300,000 in 2 years. So 2 turtles and a sloth are making about $150,000 per year. So what did I just do? I found the slope of that graph, which was, again, 300,000 divided by 2. 3 penguins might be a little trickier to do, but again, we can just kind of guesstimate and say that this is about at 100. And this one right here is about at 4. So looking at this, they did $100,000 in 4 years. So 100,000 divided by 4 is 25,000 per year for the 3 penguins. So who raised more money per year? We're going to say 2 turtles and a sloth, definitely. Okay, question, did we have to actually go through and find the slope of each of those? No, we didn't have to. We should start getting used to realizing that the steeper the slope, the steeper the graph, the greater the slope. So we could have just visually seen that this line was steeper than this one. And that's what we're going to say. We're going to say that their graph is steeper. So bigger slope, 150,000 compared to 25,000, steeper graph. Therefore, they made more money per year. Okay, next one. Now, the Slow and Sloppy 7 were so excited after the concert that they are planning on hosting a walkathon to raise money for the local Relay for Life team. They will ask people to donate a certain amount of money for each lap they walk on the track, and they plan to walk from midnight to 8 a.m. Abby, one of the groupies, wants to ask $2 per lap. Jace, another groupie, set up the following table to show how much money he wants to ask per lap. So question, who's asking for more money? Well, Abby, we know her information right away. We know Abby is asking 2 per lap. Jace might take a little bit more looking into because, again, he set up a table. So what are we looking for? We're looking for the change in money. It looks like we have $3 in the change in laps for every 2 laps. Okay, so $3 per 2 laps. What is that? Looks like, again, the unit rate of this is going to be $1.50 per lap. Okay, so I'm going to put that over here. Jace equals $1.50 per lap. So who is asking for more money? Abby. Explaining, we did that by looking at our, basically finding the slope of his equation over here. Okay, one more of these. It says that Penny and Charles would rather set up equations to determine how much money they'll get. They are as follows. So Penny has donation equals 4 times lap. Charles equals donation equals 350 times lap. Again, D is donation and L is lap. So who is asking for more money? This is basically just translating that equation. What does it mean? Penny looks like she's asking $4 per lap. Charles is asking $3.50 per lap. So who is asking more money? Penny is asking for $4 per lap. and Charles is asking for $3.50 per lap. So Penny is asking for more. All right, so what we did was we compared different functions. We compared them by looking at them in a graph, realizing the steeper the line, the greater the slope. We compared them just verbally to a table, looking at that table and having to find the slope out of it. And then we looked at it with equations, translating those equations and understanding what those equations mean. And that's what we're doing in this section. So go ahead and get out the notes and vocab. Objectives are to compare two different proportional relationships represented in different ways. Again, there's that proportional word. And then compare properties of two linear functions, each represented in different ways. So basically just looking at tables and graphs and equations and understanding what they mean and being able to compare them. So comparing two functions. Functions can be represented by a table, graph, equations, or words. You can compare the two functions represented in the different forms. So example 1 says a zebra's main predator is a lion. Lions can run at a speed of 53 feet per second over short distances. The graph at the right shows the speed of a zebra. We're supposed to compare the speeds. Okay, well, again, in words, they tell us that a lion is 53 feet per second. They say this graph is telling us about the zebra. So we're going to have to go over here, and again, when we're comparing their speeds, we're looking at the slope of this. How fast did they go? Looks like it goes through 0, 0, but let's go ahead and check the slope of this. 118 minus 59 is 59. So it looks like that he is going 59 feet, which is our rise, over 1 second, which is our run. So a zebra, 59 feet per second. And again, how did I find that? I took 118 minus 59 and I divided that by the 2 minus 1. I found the slope of it. So I found out 59 feet in that 1 second. Found the unit rate of this proportional equation. Okay, so compare their speeds. A zebra can run faster than a lion over a short distance. Okay, so there we compared words versus a graph. Okay, this is a little bit different than our guided practice. I had to use a different book, but go ahead and try this got it problem. Same concept, we are looking at a car having 22 miles per gallon. The SUV, we had to look at this graph and figure out the slope. Again, it does look like it goes through 0, 0, so we could say, just looking at this first ordered pair, it goes 19 miles per 1 gallon. So the SUV, 19 miles per gallon, compare their gas mileage. It looks like that car has better gas mileage. Okay, I did set up the slope equation over here just so we can get used to what that looks like. Again, if we know it's a proportional relationship, we don't have to do that. Up here, again, same thing. We know it's proportional because it goes through 0, 0. I could have just said 59 feet per 1 second. But I liked using that slope formula to keep me in practice. Okay, example 2. The function m equals 140h, where m is miles traveled in h hours, represents the speed of the first Japanese high-speed train. The speed of a high-speed train operating today in China is shown in the table. Again, we're assuming that the relationship between the two quantities is linear. So we're supposed to compare the function's rate of change. All right, we have an equation versus a table. We have to look at this equation and understand what this is saying. Miles are 140 per hour. So that's what we're going to write for, we're comparing the Japanese high-speed train. That is saying that it goes 140 miles per hour. Okay, We just translated that equation into a sentence. Here we're going to have to do a little bit of math. Again, we're going to have to find the slope of this equation. What is 434 miles minus 217 miles over 2 minus 1? Well, 434 minus 217 is going to give us 217 miles in 1 hour. So proportional, which makes sense because in no hours we haven't traveled anywhere. So China is 217 miles per hour, which means that China's train travels faster. Okay, don't always assume that we can look at that first number and say, oh, well, I know it's 217 miles per hour. Later, we're going to see non-proportional more often, so we do have to get used to using that slope to find that rate of change. If you ride each train for 5 hours, how far will you travel on each? Well, let's look at this. Japanese is 140 in 5 hours. We have China, which is 217 in 5 hours. Okay, handy calculator. So we have 140 times 5. We have 217 times 5. So it looks like we can go 700 miles and 1,085 miles. Just getting us used to substituting and evaluating a function. Go ahead and try that for this got it problem. Okay, first step is to translate that equation. M represents the number of movies, W represents weeks. So that means that they are getting 7 movies per week. Games, we had to do a little math in here saying that it looks like we get 3 games per 1 week. So there's our slope, 3 games per week, which means that the store receives more movies and games. And then again, now we are evaluating how many new movies and games will the store have in week 6. So substituting that 6 in and evaluating, we should get 42 movies and 18 games. All right, moving right along. Financial literacy. It says Angela and Benjamin each have a monthly cell phone bill. Angela's monthly cell phone bill is represented by this function, where X represents the minutes and Y represents the cost. Benjamin's monthly cost is shown in the graph. Okay, so now we have a little bit different information here because look at Angela's monthly cell phone. We're going to have to figure out what this means. We have 15 cents, X represents minutes, Y represents the cost. So it looks like it's 15 cents per minute for her plus this $49. So that's probably just her monthly bill. Okay, so I'm going to go ahead and write that down. Angela pays 15 cents per minute plus $49 because it does say monthly bill, $49 per month. Maybe I'll just say per month. It's kind of hard to use the word per there because we're used to understanding we're multiplying that by per month. Okay. Looking at Benjamin, it looks like if he doesn't use any minutes, he's already at $60. So that is telling me that Benjamin pays, and I'm going to put $60 over here per month. Okay, then I have to look at how much it is per minute. So this is where my slope comes into play. Okay, I have 72 minutes or $72 versus that 60 minutes. $72, goodness, over 120 minus 0. So it looks like it's going to be $12 for 120 minutes, which gives me 10 cents per minute. Okay, so Benjamin pays 10 cents per minute plus $60 per month. Okay, so we understand that. We understand the real world concepts of that. Here it says we're supposed to compare the y-intercepts and the rates of change. So now we're actually looking at it graphically. Y-intercepts. Looking here, I understand this is the y-intercept. It's a little bit harder to see in equation, but if we graph this for Angela, if she didn't have any money, if she didn't do any minutes, she would already be up here at 49. So her y-intercept would be 49, his intercept is 60. These then are going to be our y-intercepts. So this information deals with our y-intercepts. Okay, then we look at that rate of change, aka slope. Notice what we did to find Benjamin's slope. We had to use a slope formula. We found out that it was 10 cents per minute. Same thing up here. If I started at that 49, I would have to go up 15 cents per every minute. So there's my rate of change, or there's my slope. So looking at this right here, this is my rate of change. Okay, we haven't really gone over this, but this is actually a nice introduction to what we're going to do next chapter. So what does all of this craziness mean? We're going to compare this. Okay, it looks like Angela pays less per month, but Benjamin pays less per minute. So that's what I'm going to put. Angela pays less per month. So her y-intercept is smaller, but Ben pays less per minute. So his slope is smaller. Okay. Last question. What will be the monthly cost for Angela and Benjamin for 200 minutes? Well, Angela's not so bad because we had an equation up here. So we know that Angela is going to have to pay her 15 cents for those 200 minutes, and then she's going to have to add on 49 for her monthly bill. Benjamin, even though we just have a graph there, we can go ahead and use this right here. We know that Ben is 10 cents per minute plus his $60. Okay, so now that we understand how to evaluate this, let's go ahead and evaluate 15 cents for that 200 minutes. And we are adding 49 onto that. So Angela's paying 79 bucks. Benjamin is going to pay 20 for that, plus 60 for this, 80 bucks. So one extra dollar. Angela, $79. Benjamin, $80. So just getting back into the habit of substituting and evaluating. Okay, go ahead and try that. Again, try to write it out as a sentence and then understand what that sentence is. Compare the y-intercepts. Figure out which piece is the y-intercept, which piece is the rate of change. Okay, Mandy's information is laid right out there with $3 per hour plus a $29, probably a membership fee. Sarah, a little bit different. We see right away that she has a $40 membership fee. We had to figure out how much it was per hour, so I used the slope formula, 51 minus 39 over 4 minus 0, and found out hers was $3 per hour too. So the dollars per hour is the rate of change. That y-intercept is our membership fee, because even without any training, we still had to pay that money. So looking at this, they both have to pay the same per hour, but Mandy's membership fee is cheaper. And then again, they ask what's the total cost after 4 hours. So plugging in that information, you should have received 41 and 52 bucks. Okay, looking at putting all of that together now and tying this into a multi-step problem. It says that Lorena's mother needs to rent a truck to move some furniture. The cost to rent a truck from 2 different companies is shown in this table and graph. So Big question. Which company should she use to rent the truck for 40 miles? All right, so let's go ahead and focus on Crosstown Mowers, so CTM. We got to find out a couple things. First off, how much does it cost just to rent the truck? It looks like our y-intercept right here. So I'm going to say $30 to rent truck because, again, looking at that with driving no miles, I already have to throw in 30 bucks. Now I have to figure out how much it costs per mile. So how much is it per mile? Well, I'm going to find that out by looking at the slope. It looks like we went up $10 in 5, 10, 15, 20 miles. Okay, so the rise was 10, the run was 20. So $10 per 20 miles. Looks like that's 50 cents or 1/2 of a dollar per mile. So I'm going to say 50 cents per mile because again, I looked at that slope. I rose and I ran 10 by 20. Now let's go ahead and look at Ron's rental and see if he has a better deal. So Ron's rental. Okay, I'm going to actually start. So again, we need to figure out how much it is just to rent the truck and how much it is per mile. Okay, a little bit harder to see this in a table, so let's go ahead and look at what's going on. Between 10 and 20 miles, we went from $25 to $50. So looking at that, 50 minus 25 will give us the cost of 20 minus 10 miles. So it looks like it's $25 per 10 miles, which gives us $2.50 per mile, which is a whole lot more than our 50 cents per mile up here. Okay, now we have to figure out how much it costs to rent a truck. So again, we're looking for that y-intercept. Remember, the y-intercept is when our x value is 0. So let's go back one in time. So if we went from 10 to 0 miles, that means that we have to subtract $25 from our cost. Look at that, $0. So it's $0 to rent the truck. So he went a little bit different way about it. There's no rental fee, but it is definitely a little bit more per mile to rent the truck. Okay, so now we finally figured out all of the information about this. We haven't even answered the question yet. Which company should she use to rent a truck for 40 miles? So now we're going to go through and actually plug it into the equation. So Crosstown Mowers, 50 cents for those 40 miles, plus the $30 to rent the truck. Okay, Ron's rental is $2.50 per those 40 miles, but then we don't have to add on anything. So we're going to see who has the better deal. Plugging that into our handy dandy calculator. We've got $50 versus calculator that works a little bit better, $100. So who should she use? Crosstown Mowers, most definitely. Okay, so final answer on this, Crosstown Mowers will save her $50. So maybe Ron has a good idea of not having rental costs, but he might need to drop it down a little bit per mile. Okay, one last got it problem. Go ahead and try that on your own and see what happens. Okay, Juan's information is pretty straightforward. We know that he saves $5 per week. Jesse's is a little bit harder to look at because it's in a table. So always go for figuring out that rate of change first. It looks like, again, 19 minus 16 divided by 2 minus 1. He's going to save $3 per week. Okay, but that's a pretty big number for being week 1. So we know that he must have some money saved away. So again, I'm going to reverse one step, subtract a week, which means I'm going to subtract $3 from that and realize that he has $13 already saved. Okay, so I have the information I need. Now I'm going to go ahead and answer this question. Who will have more money saved in 8 weeks? So substituting 8 in, evaluating, Jesse's got $38. Juan, though, because he's saving more, he has a greater rate of change, so he is actually saving more money with his $40. Okay, again, just really getting used to analyzing all of these many different ways that we can look at relations and comparing them and understanding that comparison. Okay, you are ready for this section.